today's lecture I will start next module which is reliability assessment of power distribution networks. Okay. And in this module I will talk about some of the approaches with which a distribution utility assess the reliability of the network, because at the very beginning I mentioned that reliability is an important aspect for power distribution network, and most of the outages and most of the faults in power system occur in power distribution networks, and customers who are connected to that network definitely get affected, and this is something that an utility cannot avoid. So, these outages and all these things cannot be fully avoided, but we need to have some proper analysis, so that we can reduce the magnitude and we can reduce the frequency of those kind of outages. Okay. So, these things I will discuss in detail in this module. Okay. So, first of all, one has to understand the difference between outages and interruptions. So, there are two terms we use in power system or in distribution system. One is outage of an equipment, another is interruption. Okay. Both the terms are having different meaning. So, in this particular slide I will give you the definition of outage or outages, and I will talk about different types of outages. In the next slide I will talk about the definition of interruption and what are the different types of interruptions generally occur in a typical power distribution systems. Okay. So, the definition as per Ganguly book, which I follow for preparing this lecture as well, outage is defined as non-availability of operation of certain equipment. Okay. So, outages is the defined as non-availability of operation of certain equipment of certain lines, or this certain equipment stands for any type of equipment which is connected to a power distribution network, which is associated with a power distribution network, which may include a power transformer located in the substation, which may also include circuit breaker, which is the main switch connected to a particular feeder. So, any kind of equipment. Okay. So, non availability of any kind of equipment is called outage. Okay. So, this is a common term that practicing engineers they follow. Okay. They usually tell if you visit any power plant or any distribution substation, they often use that this particular equipment, this particular breaker is in outage. Okay. And it needs maintenance. So, this outage means non availability, any sort of non availability of any particular equipment called as outages. And most importantly, this outage may or may not cause interruption. So, an outage of any particular element may or may not cause interruption. Okay. So, this is what the basic difference of outage and interruption. Okay. So, interruption means it is a loss of service. I will define it in the next slide. It is the loss of the service to some customers, but this type of interruption may not occur due to outage of any equipment in a distribution network. Okay. And there are three different types of outages. One is called forced outage, where any equipment is taken out of service on an emergency basis. So, this is called forced outage, when the utility operators they need to take out any equipment from the service, then it is called forced outage. Okay. And this occurs whenever there is an emergency situation. Okay. There is another called scheduled outage or planned outage or preventive outage. So, this is basically to take out a certain equipment for preventive maintenance. Okay. So, many times if you visit any substation or any power plant, you will see the operator, they can understand with their experience that that particular equipment get faulty, it is not performing as per its full potential. Okay. So, they can predict that this particular equipment get faulty within certain span of time, and therefore, they take it scheduled outage whenever they require it. Okay. Whenever they will get a favorable time to take this outage. So, this happens normally, this happens every day. If you visit any sort of substation or any power plant, this process of taking a schedule outage of any particular equipment is a routine work for them. Okay. Then another possible outage is partial outage, when an equipment is operational with reduced capacity. Okay. So, this is also occurs in a typical power plant. If you visit even in the distribution substation, any particular equipment which is not performing well, if the operator understands that, then the operator take an alternative equipment which performs the similar work to assist that particular equipment, and both equipment are usually work with their reduced capacity. So, this is called partial outage. Okay. Now, here you can see the definition of interruptions. Again, this definition I took from Turan Ganen's book. Okay. So, according to this interruption is the loss of service to one or more consumers. Okay. So, interruption causes loss of service, whereas outage may or may not cause. Okay. That is what the major difference, and an interruption may occur due to one or more component outages. Okay. So, due to outage of one equipment, for example, suppose if you visit any power plant, you will see that to perform a certain task, suppose we need electrical motor, and two motors are sufficient to perform this task, but this in power plant if you visit, then you will see usually we have more than 2 such kind of motors. Now, what are the purposes of having that? This is to improve the reliability, because if we have 2 motors and one of them suppose become faulty, then we use the alternative motors to supply or to have the same work. Okay. And this is to assist one particular equipment, and this is normally kept in any type of power station or substation. Okay. Now, interruption can be of following types. So, there are 4 different types of interruption. Okay. If you categorize this interruption event, we can categorize them based upon the time or based upon the time the interruption sustains. Okay. So, one is called scheduled interruption. This is because of scheduled outage. So, if the scheduled outages cause any sort of loss of service, so we have scheduled interruption. We will categorize that particular event as a scheduled interruption. Okay. Another is momentary interruption, where this interruption sustains for a very short period of time, just like a few seconds. We call that interruption as momentary interruption. We also have temporary interruptions, where the interruption sustains for few minutes, and we also have sustained interruption, where this interruption sustains for few hours. Okay. So, based upon basically the time of occurrence or the duration of occurrence, we can categorize these interruptions into these 3 categories. One is momentary interruption, one is temporary interruption, another is sustained interruption. Okay. Now, what this utility can do if there is an interruption occurs. Basically, see, when this power system was developed in the beginning of 20th century 1920 1930, that time interruption was not given any sort of priority for analysis. Okay. So, interruption means customer would get affected and customers its customer loss, but when slowly this all sort of production units they started by this electrical energy, then a few minutes of interruption causes, particularly for the industrial customers, a huge amount of production loss. And slowly the this our civilization get digitized, these digital computers came, and during that time interruption becomes an important demerit for these customers. So, we cannot even sustain a few seconds of interruption, which may cause a serious damage. So, what could happen if any sort of interruptions occur, or what the utilities practice for analysis of this interruption. So, according to an IEEE committee report, the following information should be included to prepare an equipment outage report. So, usually this electrical utility or distribution network utility, they prepare a outage report, in which they should mention the following things like type and design and manufacturer of the different equipment, okay, date of installation. This will give them the idea that what sort of preventive maintenance will require. Then mode of failures of a particular equipment, cause of failures, okay, times of failure and type of the outage. So, those things they should mention in that particular report, and this report helps them to facilitate the future activities, okay, which could help this distribution network operator to improve the reliability. Now, one thing that I should mention at this point is most of the distribution networks fault occur due to some non-technical reason, either due to some non-technical reason. Now, what are the non-technical reason possible? Suppose if we have simply a tree branch which hits a live conductor of distribution line. So, it will cause some interruption, okay. But that interruption might be momentarily cleared or it may sustain. Okay. Now, during this bad weather, this is a frequent type of interruptions. Okay. When the storm or cyclone hits in a particular area, this is a typical type of interruption that customer used to face. Every one of us already faced this type of interruption. But apart from that, there are some animal related interruptions. For example, if there is a rat or squirrel which hits that insulators which is supporting a live conductor of a distribution line, then interruption may occur. Sometimes snakes also hit. So, these are some animal related non technical interruptions. Okay. But apart from that, some of the interruptions also occur due to poor maintenance of the equipment. If we find that any insulators which is already aged or almost damaged, so this needs replacement, timely replacement. If it is not done, then of course, it will cause an interruption. So, these are the typical interruptions that a distribution network customers may experience. Okay. Now, what are the major challenges we have for this reliability assessment? So, first of all, if that type of the interruption or type of the outages are not properly written in the report or it is not properly recorded, then it will be really challenge to improve the reliability of a network in future. So, insufficient data for this reliability assessment is one of the reason. A proper way of recording of all sort of events would facilitate an accurate reliability analysis, but if we do not have so, then we can't do this. Okay. Now, most of the interruptions of the distribution networks, as I said, are caused by the severe weather related interruption and inadequate maintenance, which I mentioned already. So, most of the interruptions of distribution network are related to either weather related interruption, which caused by storm or cyclone or simply a tree branch hits in a particular distribution line and so, and also some animal related interruptions, but those things should be properly recorded, so that we can avoid this. And also inadequate maintenance of all this equipment is another reason. Okay. And also distribution network reliability can be improved by timely identification and response of those failures. Okay. Now, in next few slides we will talk about different types of indices, which are formulated traditionally by distribution network planner or designer in order to assess the reliability of a typical distribution network. Okay. And these reliability indices can be further categorized into three different types. One set of indices are there, which are only for sustained interruptions. So, if our interruption event is of sustained interruption, it sustains for few minutes to few hours, then we have some indices to formulate, to quantify, to numerically represent those events. Okay. And also there are some indices which work for only momentary interruptions. Okay. I will come to that. Another indices are there, which are called load or energy based indices, which are very important for planning. These are very important for planning or designing of power distribution networks. Okay. So, we will discuss these indices one by one. Before that, we should know what are the usage of those reliability indices. Okay. So, most of the utilities they use one or more reliability indices to understand how the distribution network is performing. Okay. So, the performance, these indices almost used by every electric utility to assess the performance of their network. Okay. And there are some indices, as I mentioned, which will work for sustained interruption, but may not reveal that momentary interruption. So, that is why we have different types of indices, and every indices has a significance. Okay. So, those things I will discuss in next few slides. Okay. Now, what are the benefits of this reliability based study? So, a reliability assessment study can help to quantify the impact of design or design of the improvement options. So, this is a very crucial thing, that see, if we cannot avoid any sort of interruption, but if we properly analyze it, then we can avoid the future in such kind of interruptions. Okay. Now, what are the typical improvement options that can be done with this predictive reliability model, or by analyzing this reliability appropriately? So, we can design the few new feeders, or we can go for when we will do for feeder expansion, this will be helpful. We can also take the proper strategy for load transfer between the feeders. We can take proper planning tools for new substation design and substation expansion, new feeder, for developing new feeder tie lines, for locating the sectionalizers, for feeder automation and replacement of aged equipment. Okay. Now, as I mentioned, why this reliability analysis has been done traditionally. This because reliability is associated with the economy of the system, okay, and there are some costs involved with this reliability study. So, there are three typical costs involved. One is called investment cost, this is the utility side cost to achieve a desired level of reliability. So, if we suppose quantify this reliability by a certain index and I want to improve this index values from one value to another value. So, in order to do so, we need to have some infrastructural change, okay? And this infrastructural change needs some sort of investment, and this is called investment cost to improve the reliability. So, this is utility side cost which requires to improve reliability to a desired level. Okay. Now, there are another two types of cost which involve to the customers. So, these two costs are customer side cost, customer side costs, and this is of course utility side cost. Okay. Now, these costs represent this customer's agony or customer loss due to a certain type of interruption. So, one is called customer interruption cost, which includes the cost of production loss or process industries. So, as I said, these industries they suffer a lot due to a poor reliable network, okay, or due to an certain interruption of service. So, their loss can be measured with this cost function, which is called customer interruption cost. Okay. Another cost is there is called customer damage cost. This is somewhat related to customer side, but this is somewhat related to customer side, but utility needs to provide this cost as a penalty. Okay. This is a penalized cost, you can say. This customer damage cost is somewhat a cost which should be penalized to the utility due to certain events of interruptions. Okay. Now, if we plot this cost, these three different types of cost with respect to the system reliability. Suppose this system reliability is represented by some index whose 0% value means it is totally unreliable and 100% value means it is fully reliable. So, 0% value of this system reliability means is totally unreliable and 100% corresponds to fully reliable, which may or may not physically exist or which may not feasible even to make something fully reliable, but let us assume that this is the index which represent the degree of reliability. Okay. And 0% means totally reliable and unreliable, and fully 100% means fully reliable. And here in this particular vertical axis, it represents the cost. Okay. Now, how this utilities cost or utilities investment cost will vary from if we want to improve reliability from 0% to 100%, of course, it will increase as we go for higher level of reliability, utility needs more investment. Okay. So, it increases like a non-linear form. And how this customer damage cost or customer interruption cost will vary? So, this will gradually get reduced if we go for higher degree of reliability, and at 100% reliable network it will be of course 0. Okay. So, this value of this interruption cost would be 0. So, this value of the interruption cost would be 0 if the network is fully reliable, which may not feasible practically, but it is like that. Okay. Now, if we take a summation of these two costs, although they, if you look at the way they are varying, they conflict with each other. So, these two cost function, or these two cost components conflict with each other. Meaning that when cost of investment is increasing, interruption cost is getting reduced. When cost of investment is less, the lowest value, interruption cost is at highest value, and vice versa. When interruption cost is at 0%, cost of investment is very huge. Okay. Now, although they conflict with each other, but if we aggregate, because both are ultimately represent cost, or both units of both the functions are same, then how these characteristics we will get? We will get a characteristics like this. Although it may not appropriate all the time to to aggregate both the cost function to make a same cost function, but if we do so, then we will get this type of characteristics, where there will be a point where you will get optimal cost, in meaning that the minimum cost and corresponding to that there is a optimal reliability level. So, this optimum cost or minimum cost corresponds to the optimum reliability level. So, sometimes this is taken as a standard for an utility to understand that how much investment we will do to improve the reliability of the network. Okay. Now, in next few slides we will talk about different reliability indices. First, let us start with the index psi phi. Okay, the index psi phi. This psi phi, it stands for System Average Interruption Frequency Index. So, SAIFI. So, this psi phi stands for, psi phi is the acronym to represent this System Average Interruption Frequency Index. Okay. So, this is a common form of reliability index many utilities use to assess the reliability of their network. Now, what is that psi phi index or this psi phi? This index is designed or formulated to provide the information about average frequency of sustained interruption. So, this index is applicable for sustained interruption. You can remember that I said that there are three different categories of this reliability indices. One is for sustained interruption, one is for index for momentary interruption, another is index which are used for load or energy related activity. Okay. Now, this index is in the category of sustained interruptions, okay, and this gives the frequency of the interruption. So, the numerator is total number of customer interruption and the denominator is total number of customers served. It means that suppose I have a total customer under a distribution network is let us say 100, and there is a event of total number of interruption, total number of interruptions is let us say 70, then simply this psi phi is equal to 70 by 100. Okay. So, this 70 is giving you total number of interruptions and it is normalized with total number of customers, that is 100, which gives you the index psi phi. Okay. So, this gives an interruption frequency index. Now, next index is CTAIDI, which is System Average Interruption Duration Index. Okay. So, this SIDI, this stands for System Average Interruption Duration Index. So, previously that index was System Average Interruption Frequency Index. Now, here we have System Average Interruption Duration Index. So, just looking at this term duration, you can understand that it is related to the interruption duration. So, previously that index was related to interruption frequency, now it is related to interruption duration, and it is also in the category of sustained interruption. So, this index is also in the category of sustained interruption. So, this index is used, it is basically a ratio as customers minutes of interruption or customers duration of interruptions to the total number of customers served. So, denominator is same as that of previous index, that is psi phi, but numerator is different, is meaning that numerator gives total number of customers interruption duration. Okay. So, denominator is total number of customer as same as psi p, but numerator is different, that it gives the total number of customers duration. Okay. So, this index gives you that much of duration, that much of minute per individual customer. Okay. The next index is CTAIDI, that is customer average interruption duration index. Okay. So, it is also a duration index, that is why its numerator is same as that of CTAIDI. So, this numerator is same, numerator of CTAIDI is same as CTAIDI. Okay. But denominator is different, denominator of CTAIDI was total number of customers served, but here the denominator of this CTAIDI is total number of customers interruption. So, this index gives that much of hour or that much of minute interruption per that many interruptions of the customer. Okay. Now, if you look at this denominator of CTAIDI, this denominator is same as the numerator of psi phi. And since this psi phi and CTAIDI, the denominator are same, that is total number of customers served. So, if we take the ratio of CTAIDI and psi phi, whatever you will get, that will represent CTAIDI. Okay, CTAIDI. So, this gives customer average interruption duration index. Okay. Now, next index is CTAIDI, that is CTAIDI. Okay. So, it is also some sort of interruption duration index as CTAIDI and CTAIDI. Okay. But it has some difference. What is the difference? So, here for each type of reliability index, there is a difference, and that difference one has to notice. Okay. So, that you can understand the difference of one type of reliability index to the other type of reliability index. Now, in this particular reliability index, here denominator of this reliability index is something different, which we have not discussed till this time. Okay. Numerator is total number of customers duration as sort of CTAIDI. So, the numerator is numerator of this CTAIDI is same as the numerator of CTAIDI. Okay. So, this CTAIDI numerator is total customer interruption duration. In fact, CTAIDI numerator is also same as the CTAIDI, which is total customers duration. So, these numerators this of CTAIDI is same as that of CTAIDI or CTAIDI. Okay. And denominator is something different. This denominator is total number of customers who have experienced a sustained interruption during the reported period. Now, in previous indices, we got this denominator mostly as total number of customers served or total number of customers interruptions. Okay. Now, there are some customers who will experience multiple interruptions, So, we cannot identify the agony of those customers with these indices. Okay. It may so happen that in this denominator of this CTAIDI and this numerator of this psi phi, where we have total number of interruption, this total number of interruption is 70, but it may so happen there is a customer who experience 7 times 7 interruptions. So, this 7 interruption is inside this value of 70, but those customers cannot be identified in this index. Okay. So, if we just exclude this the customers in customer interruptions who experience multiple interruption, and these multiple interrupted customers, if they are counted only once, then whatever value we will get, that will give you total number of customers who have experienced a sustained interruption during this reported period. So, here this CN excludes the multiple interruption or the customers who are having multiple interruption or these interruptions which occur multiple times for a particular customer, and in order to have a value of this CN, we exclude this multiple interruption event, and we only count that only what are the customers who are affected or who got this who experienced this interruption. So, CN means total number of interrupted customers, or total number of customers who experienced interruption. So, CN stands for total number of customers who experienced interruptions. And definitely this value of CN will be lower than this total number of customers interruptions. Okay. And that is why this CTAIDI value will be higher than this CTAIDI. Okay. This value will be, because CN total number of customers, if there is an event of multiple interruption, and if there is not at all any event of multiple interruption, this value of CTAIDI will be equal to CTAIDI. Okay. Now, next reliability index is CAIFI, that is similar to CAIDI, we have CAIFI, that is called customers average interruption frequency index. Okay. So, customers average interruption frequency index, which gives the average frequency of sustained interruption. This all whatever we discussed, whatever indices we discussed so far, this all indices are for sustained interruptions. Okay. To analyze the sustained interruption. Okay. So, this index gives the average frequency of sustained interruption for those customer experiencing the sustained interruption. Okay. Again, the denominator of this CAIFI is CN, which means that customer who encountered only once regardless of the number of times interrupted. That means, again we eliminate this to consider any customer who experienced multiple interruption, to consider them multiple times, and that is why this CN is basically representing the actual number of customers who got interruption, who experienced interruptions. Okay. And this CAIFI in its numerator is total number of customers interruption, that same as that of this CAIFI, and the denominator is different. In CAIFI denominator was total number of customers, here the denominator is total number of customers who experienced interruptions. Then there is another index which is called ASAI. Okay. This index represents the fraction of time that a customer had power without interruption during 1 year of the defined or the defined reporting period. Okay. So, here then for determining this ASAI, the numerator is customers hour service availability divide, and denominator is customers hour service demand. Okay. The next index is ASIFI, it is average system interruption frequency index. Okay. So, here this is an important index for the areas of serving industrial or commercial customers. Why we are saying so? Because ASIFE is basically a ratio of connected KVA interrupted to the total connected KVA surged. Okay. So, it gives that how much KVA was interrupted with respect to how much KVA was surged. Okay. And why it is important for industrial or commercial customers? So, they need uninterrupted power. So, with this index an utility will understand that how much power or energy delivered to them in comparison with what they demand. Okay. So, previously that this index was energy based index, now here this load based index or KVA based index. Okay. Now, there is another reliability index which is called average system interruption duration index, that is ASIDI. So, this index is formulated with the same philosophy of ASIFI, but it provides information of system average duration interruption. Okay. So, here this in ASIDI, this numerator is connected KVA duration interrupted. So, which is somewhat similar to ASIFI, where the numerator was connected KVA interrupted, okay, but here connected KVA duration interruption. Okay. And its denominator is total connected KVA surged, which are same in ASIFI, total connected KVA surged. Okay. So, with this I will stop this lecture.